A very good morning, students. So today I am going to start a new chapter. Chapter 2 is matter around us pure. Welcome in one branch of science, and this is your chemistry, right? So all of you will be very much aware of this term matter now. We already did in chapter number 1. So what do you mean by the matter? Matter is something which occupies the space and have mass, right? So is matter around us pure? Now one more term, pure. What do you mean by the pure? It's a very general and common term, right? So what do you mean by the pure? In general, pure means what? Having no adulteration, right? But if the same question, if we will ask to a scientist, what he will say that if all the constituent particles of that substance are same in chemical nature, that means the given substance is pure. So now look around you, the matter you are using in your day-to-day life, like milk, ghee, table, chair, air, each and everything. Visualize it from the point of view of a scientist now, right? So now analyze them and tell me whether they are pure or not. Pure means what? That if the constituent particle of that substance are same in chemical nature throughout, you will call it as pure. Okay. So now what you will observe, air is present around you. What do you think? Is it pure? Milk you are drinking, is it pure? No. The milk is a combination of water, fat, protein. The same way, air is a combination of so many of gases, right? So many gases. So as we look around, we can see that most of the matter around us exists as a mixture. Again, new term, mixture. What is a mixture? Mixture is what? When more than one pure form of the matter is present, we call it as mixture. That means mixture is a combination. What is a mixture? It is a combination of more than one pure form of matter. We call it as mixture. So as we look around, we can see that most of the matter around us exists as a mixtures of two or more pure substances. For example, you can see so many examples like the soils, minerals, etc. Okay. So here the mixture. Now see, as you just now, as I said, that what is a mixture? When more than one pure form of matter is present, we call it as mixture. That means minimum two pure form of matter, right? So now here I have written the one more thing, that types of mixtures. So types of mixture means what? When the combination of the constituent part depends, like how you will define these mixtures as, or how you will categorize it as types of mixture. It depends on nature of components, how the components are participating for the formation of a mixture, right? If the uniform composition is present throughout, then we call it as homogeneous mixture. What we call as homogeneous mixture. When the uniform composition is throughout, okay, and when the same combination is not present, that means if we observe the non-uniform composition, we call it as heterogeneous mixtures. So for the homogeneous mixtures, you can take the so many examples like sugar in water, salt in water, table salt, right? I'm talking about the table salt for you, what you are consuming in your day-to-day life. It is nothing but your NaCl, right? In terms of chemistry, what you will say? It is NaCl, right? So NaCl in water. In the same way, for the heterogeneous mixtures, you can take the example of oil in water. Even any any combination you can select on your own, like the iron filling with the salt and sugar with the salt, right? So in the same way, you can show the so many combinations for the example of your heterogeneous as well as your homogeneous mixtures. Okay. So in your NCRT, they have given you the one experiment regarding how you will define that types of the mixtures. Here I told you about the homogeneous and heterogeneous. Homogeneous means uniform composition throughout, while heterogeneous means non-uniform composition of the constituent particles in a given substance. Okay, so in your NCERT they have given you one activity. What they did, they have shown that it's suppose here is a class. Okay, and what they did, they divide this class into the four different groups, like 1 2 3 4 A B C D, something, anything you can select. Now for the group A, what they said that group A takes a beaker containing the 50 ml of water and one spatula full of copper sulfate powder, CuSO4 powder. It is blue in color. And for the group B, what they are saying that group B takes the 50 ml of water and two spatula full of copper sulfate powder in a beaker. For the group C and D, they can take the different amount of copper sulfate and potassium permanganate. What is potassium permanganate? KMnO4. Okay, or the common salt, that is NaCl, and mix the given compositions, the given components to form a mixture. Okay. Now what they are doing, they observed it. Okay, what happened? So what they observed from it, what they observed that in case of the first one, so the group A and B have obtained a mixture which has a uniform composition throughout, because what they did, there's all the copper sulfate. Okay, such mixtures are called the homogeneous. Homogeneous means uniform composition throughout. So for the AB, because both of them are having the same composition of copper sulfate in water, right? So it is called as homogeneous mixtures or the solutions. Some other examples of such solutions are salt dissolved in water, as I already gave you, sugar in water, right? So now compare the color of the solutions. In case of A and B, in case of A you will observe the not that much of color as you will observe in case of your B, right? But both of them will show the change in color. While for the group C and D, they have obtained a mixture which contains physically distinct parts and have the non-uniform compositions. Such mixtures are called as your heterogeneous, as I already gave you the examples. Here you can take the different examples again. In another activity, what they did, they again divided the class into the four parts and they distributed like few crystal of copper sulfate to group A, one spatula full of copper sulfate to the group B, chalk powder to the group C, and few drops of milk to the group D. Just think about it. Now what? Each group should add the given sample in water and stir properly using a glass rod. So what you will observe, just imagine the first case copper sulfate in water, second case is more copper sulfate in water, in third case chalk powder in water, and the fourth case the milk in water. So what they are trying to tell you that here is a different combination of mixtures are present, and we will explain it. I will explain you each and every terms one by one. So what are their observations, that for the group A and B they got a solution. Okay. For the group C has got a suspension, and while for the group D has got a colloidal solution. Now again the one more term I am going to introduce here, and that is what this is, that is solution. So again the question arises, what is a solution? Solution means you will imagine something which is present in liquid form, right? So in general, if I will define the solution, I say that homogeneous mixture of two or more substances, right? This is what solution. And imagination will be in terms of liquid, right? But solutions are not only, we cannot define the solution not only for the liquids, but it is true for the solids and gases. We can see the solid solutions, gaseous solutions too. What do you mean by the solid solutions? Solid solutions means alloys. Have you ever heard this term alloys? Alloys is nothing but the combination of two solid substances. Here I have given you one example of brass. Brass is a combination of copper and zinc. Okay. In the same way, gaseous solution you can take air. Right? Air is a gaseous solution where a number of gases are present in different percentage. Right? So that is all about the solution. Okay. So a solution is a homogeneous mixture of two or more substances. You come across the various types of solution in your daily life, right? Air, sugar in water, salt in water, right? In the same way, you can see the different the vessels you are using in your kitchen, right? These are also the alloys. And the same way, you can see the so many examples. So what do you mean by the, now can you define this term alloys? So alloys are mixtures of two or more metals or a metal and a non-metal, and cannot be separated into their components by the physical methods. So here physical method means what? By the simple method, like by the filtration, by the crystallization, by the evaporation. So these are called as your simple physical means, right? But still an alloy is considered as a mixture because it shows the properties of its constituent particles and which are having a variable compositions. Okay. So I hope till now it will be very much clear to you. So in our next lecture, what I'll do, I will try to explain the further part of the mixtures besides these solutions, and maybe suspension or your colloidal solution. Okay. So keep study. Thank you.